Jai Swaminarayan. Welcome to the video lecture of chapter 14. Today we are going to start chapter 14, Mathematical Reasoning. Logic. You comment, students, for your friends that this person doesn't have any logic. So let us check how much logic you have in this chapter. So students, we are starting with chapter 14, Mathematical Reasoning, or alternatively this is also called Mathematical Logic. Now students, we are going to start with the concept of sentence and statement. Say, as far as language is concerned, say they will tell you write two statements on so and so topic, or write two sentences on so and so topic. There it is meaning the same. But students, in mathematics, sentence and statement are totally different aspects of concepts. Oh, what a beautiful picture it was. This is a sentence. Mathematics is a tough subject. This is a sentence. 3 plus 4 is equal to 9. Now, I know what is the answer, but I am saying 3 plus 4 is equal to 9. Now, you can definitely say that this is false, because 3 plus 4 is 7. Then 5 minus 2 is equal to 3. This is definitely true. So, what is the mathematically accepted statement? What is mathematically accepted statement? A sentence becomes a statement if it is definitely either true or false, but not both at a time. Say 3 plus 4 is not equal to 9. 3 plus 4 equal to 9 is the given statement, but we know that 3 plus 4 is not equal to 9, so this is definitely false. 5 minus 2 is equal to 3, definitely this is true. So, a sentence becomes a statement if I can definitely say that either it is true or false, but not both at a time. Oh, what a beautiful picture it is. According to you, it might be beautiful. According to me, it is not. So this is not universally true or not universally false. It is both. So this is not a statement. A sentence in mathematics becomes a statement if it is universally true or universally false, but not both at a time. Let us take few examples given in textbook. So pay attention. Women are more intelligent than men. This may be true for some, this may be false for some. So this is not universally true, this is not universally false, it is both. So it is not a mathematically accepted statement. What beautiful! This is an exclamation. It is not universally true or false. Open the door. It is an order. Open the door, I say. It is an order. So this is not a statement. Where are you going? This is a question tag. This is not a statement. So in mathematics, students, sentences and statements are totally different. Every statement is a sentence, but every sentence becomes a statement if it is universally true or false, but not both at a time. So there is a line of difference between a sentence and a statement. I repeat, there is a line of difference between a statement and a sentence. So, a mathematically acceptable statement is either true or false, but not both at a time. Or a sentence becomes a mathematically acceptable statement if it is universally true or universally false, but not both at a time. Then students, few more will consider. Tomorrow is Friday. Now if it was Thursday today, definitely it is correct. But if it were some other day, then it is false. So in few cases it is true, in few cases it is false. So this is not a statement, it is a sentence. Then, he is a mathematics graduate. He is a mathematics graduate. He, we don't know who the person is. So this is a sentence, not a statement. Then, Kashmir is very far from here. Now here means which reference is considered. From Bhavnagar it is very far, but maybe from other states it is very near. So this is not a statement, it is a sentence because it is not universally true or false. So a mathematical accepted statement is either definitely true or definitely false, but it cannot be both at a time. If in some cases it is true, if in some cases it is false, then definitely students, it is not a statement, it is a sentence. So don't argue with Devalman that in mathematics sentence and statement are different, whether it is different in English or not. Now let us do students example 1 of textbook that will help you to understand this more better. 8 is less than 6. 8 is less than 6. Now 8 is not less than 6, 8 is greater than 6, so this is false. So if the sentence is false universally, definitely it is a statement. Then every set is a finite set. Every set is a finite set. You know that set of natural number is an infinite set. So every set is a finite set. This you can say every set is a finite set. Is definitely false. Set of integers is infinite. Set of real numbers is infinite. So every set is a finite set is definitely false. So this is a statement. You can say sun is a star. Sun is a star. It has been mathematically or scientifically proved that sun is a star. Hence this is a statement. Then mathematics is a game. Now according to me, mathematics is a game, students. According to you, mathematics is a havoc. It is not a game. So for some it is true, for some it is false. It is neither universally true nor false. So this is definitely not a statement, but it is a sentence. Then there is no rain without clouds. Of course, clouds are necessary to bring rain. It is a scientifically accepted thing. So this is universally true. Hence, this is a statement. How far is Chennai from here? This is the question tag. From which place the distance is considered is not there. So this is the question tag. So it is a sentence. It is not a statement. So students, what we have to understand as far as the definition of statement is concerned. A statement is mathematically acceptable if it is either true or false universally, but not both at a time. I repeat, a statement is mathematically accepted. A mathematical statement is such a statement which is either true or false, but not both at a time. without any confusion, we can say that it is universally true or universally false, then it is a statement, otherwise not. Now students, let us start exercise 14.1. Which of the following sentences are statement? Give reason for your answer. There are 35 days in a month. The first question is, there are 35 days in a month. Now all of you know that a month may have either 31 days or 30 days or 28 days or 29. But none of the months, February leap year then 29 days, not a leap year then 28 days, otherwise 31 days in January, in April we have 30 days like that. So, a month can never have 35 days, this is universally false. So, I can decide that it is true or false, hence it is a statement. A sentence becomes a statement if it is universally true or universally false, but not true in some cases and not false in some cases. Mathematics is a difficult subject. Of course, mathematics is according to you, according to me not, according to somebody else yes, according to the fourth person no. So in some cases it is true, in some cases it is false, it is true and false at a time. We cannot decide whether it is universally true or universally false, hence this is not a statement. Not a statement. So definitely this is a sentence. So definitely this is a sentence. The addition of 5 and 7 is greater than 10. Addition of 5 and 7 is 12. 12 is greater than 10. This is universally true. So this sentence is a statement. Understood, students? This is universally true because 5 plus 7 is 12. 12 is definitely greater than 10. I can say this is always true. Hence, this is a statement. Then, fourth, students, the square of any number is always even number. Let us take this statement once again. The square of a number is always an even number. Square of a number is always an even number. Suppose square of 1 is 1, it is odd. Square of 2, 4, even. Square of 3, 9, which is odd. So in some cases it is odd, in some cases it is even. So in some cases it is false, and in some cases it is true. So this is not a statement. Definitely not a statement means this is a sentence. I can never say that this is universally true or universally false. The sides of a quadrilateral have equal lengths. The side of a quadrilateral have equal lengths. Now always all the sides of a quadrilateral may not be equal. Say for square it is equal, for rectangle it is unequal, for rhombus it is equal, but for parallelogram it is not. So true in some cases, false in some cases, at a time true or false. So this is not a statement, but it is a sentence. Because I cannot say that this is universally true, or I cannot say that this is universally false. Then give the answers to the following question. Give the answer to the following question, or answer these questions. This is, you can say, order, or it may be request. So this is not a statement. Because it may be a request. Request and order is another statement. 7. Students, the product of minus 1. The product of minus 1 and 8 is 8. Now all of you know that minus 1 into 8 is minus 8. And here it is given 8. So this is universally false. And hence it is a statement. This is universally false because the product of minus 1 and 8 is, students, minus 8. So this is universally false and hence it is a statement. The sum of all interior angles of a triangle is 180. Yes, correct. Universally true. The sum of interior angles of a triangle is always 180, which is universally true. So this is a statement. 9. Students, today is a windy day. Now, today is a windy day. Which day? No specification. Rainy day, stormy day, summer day. We don't know. So nothing specified. Neither universally true, neither false. Both at a time. So this is not a statement. It is a sentence. Last but not the least, all real numbers are complex numbers. Correct. All real numbers are complex number in the form of a plus 0 iota, where a belongs to r. A complex number in imaginary part 0 is a real number in chapter 5. So Aristotle shows complex numbers. So all real numbers are complex numbers in imaginary part 0, universally true. Therefore, this is a statement. So by this time now all of you will be well versed that if a sentence is universally true or universally false, then and then we can say it is a statement. But if it is true in some cases, false in some cases, then we cannot say that that sentence is a statement. So every statement is a sentence, but every sentence may not be a statement. Now, give 3 examples where the given sentences are not statement that you can give. Mathematics is tough. Today is a windy day. Please close the door. Open the door. What a beautiful picture. On this type of example, students, you can write on your own. So, exercise 14.1 is done. Students, the second sum you have to give the examples of sentences which are not statement, order, you can say request, question tags, such type of, you can say sentences are not statement. What a beautiful day, what a nice movie, etc., etc. Students, the truth value of the statement has 2 possibilities, either true or false. So if the statement is true, we write the truth value as T, and if the statement is false, students, then we write the truth value as F. So T or F are called respectively the truth values of statement. Now students, statements are denoted by small alphabets P, Q, R, S, T, U, V, etc., etc. It is not that a statement cannot be denoted by A, but the wide or commonly used symbols for a statement are P, Q, R, S, T, U, V, and onwards. Now students, the next topic is negation of a statement. Now students, the next topic is negation of a statement. Now, students, pay attention. We have the chapter of mathematical reasoning, students, in JEE Mains. But students, we do not have the chapter of mathematical reasoning in JEE Advanced. In Main, students, always one question of mathematical reasoning is asked. But in JEE Advanced, students, we do not have this topic. What is negation of a statement? Say, suppose we have a statement √3 is a complex number. I told you statements are denoted by small alphabets P, Q, R, S, T, U, V, and onwards. So I am writing a statement P. √3 is a complex number. The denial of the truth value of a statement is called its negation. If the statement is true, its negation will be opposite of true, which is false. And if the statement is false, its opposite will be. So the denial of the truth value of a statement is called its negation. Negation is not. So negation of statement P is denoted by this symbol, and this is read as not P. So if √3 is a complex number, its negation is √3 is not a complex number. Or alternatively, I can write √3 is a complex number is false. So denial of the truth value of a statement is usually called, students, negation of statement. Denial of the truth value of a statement, students, is called negation of a statement. And that symbol which I have circled and written, it indicates or denotes not P, or negation of P. So students, in this chapter we have to understand theories, and sums and questions, students, are always done on the basis of theories. Sums and questions in this chapter, students, are always done on the basis of theoretical understanding. So let us revise these two concepts once again. What is a statement? A mathematically accepted statement is definitely either true or false, but not both at a time. If in some cases it is true and if in some cases it is false, it is not a statement, it is a sentence. T or F is called the truth value of a statement. Mine, only statement has truth value. I can never say that a sentence has truth value T or F. Then what is negation of a statement? Students, what is negation of a statement? The denial of the truth value of a statement is called negation of a statement. Denial of truth value means if the statement is true, its negation is false. And if the statement is false, its negation is true. We have taken the best example. Statements are denoted by, students, the small symbols P, Q, R, S, T, U, V, and onwards. So I have written statement P, and it is √3 is a complex number. So what will be the negation of this statement denoted by negation P, even read as not P? √3 is not a complex number. Or alternatively, I would have even written √3 is a complex number is false. write it in different ways. So denial of the truth value of a statement, students, is called negation of a statement. Statements are usually denoted by small alphabets P, Q, R, S, T, U, V up to say X, Y, Z. Now students, I am doing exercise 14.2. Main question 1, part A or 1, whatever we take. Main question 1, part 1, that is right according to textbook. So students, please note down the definitions and concept of this chapter again and again. Students, the more you revise the definition, the more students you revise the concept, then indeed students you will be thorough with this particular topic. 15th chapter already we have done, 14th we have started, and after 14th chapter students will be doing probability, which is chapter number 16. Okay students, so write the negations of the following statements. P, you can say Chennai is the capital of Tamil Nadu. What is the statement, students? Remember, negation of a statement is also a statement. Negation of a statement is also a statement. It is not that negation of a statement becomes a sentence. Negation of a statement is always a statement which can be definitely told that either true or false. So what is the first statement? Chennai is the capital of Tamil Nadu. So what will be the negation of this? Chennai is not capital of Tamil Nadu. What is the given statement, students? Chennai is the capital of Tamil Nadu. What will be the negation? Chennai is not capital of Tamil Nadu. Second statement, root 2 is not a complex number. Check, statement itself is not. Root 2 is not a complex number. So negation will be root 2 is a complex number. Root 2 is a complex number. All triangles are not equilateral triangles. All triangles are not equilateral triangles. What is the negation? All triangles are equilateral triangles. All triangles are not equilateral triangles. What is negation of this? All triangles are equilateral triangles. You have to write answers on your own, students. 2 is greater than 7. What is given, students? The number 2 is greater than 7. What is negation of this? 2 is not greater than 7. Not greater than has two options, either less than or equal to. 2 is not greater than 7. The number 2 is not greater than 7, students. I told you, has two options, either less than or equal to. And last, every natural number is an integer. So every natural number is not an integer. Every natural number is an integer. That is the given statement. Its negation will be every natural number is not an integer. So if I am writing a given statement, its negation will be also a statement, students, that you should completely understand. Now students, after this we define another definition, simple statement. Now pay attention, students. What is a simple statement? And what is a compound statement? Pay attention. A statement which cannot be broken down into further statements is called a simple statement. A statement, students, which cannot be broken down into two or more statements is called a simple statement. The best example, root 3 is a complex number, is a simple statement. A statement which cannot be broken down into two or more statements is called a simple statement, and a statement which can be broken down into two or more statements is called a compound statement. For example, Q. Root 3 is complex number or an irrational number. I can break down this into two statements. Root 3 is a complex number. Root 3 is an irrational number. So, a statement which can be broken down into two or more simple statements is called a compound statement, and a statement is simple if it cannot be broken down into two or more statements. So, students, these are the total theories which we have discussed today. Definition of a statement, negation of a statement, simple statement and compound statement. Once again, a statement is simple if it cannot be broken down into two or more statements. A statement is called a compound statement if it can be broken down into two or more simple statements. So students, here we conclude the lecture. Remaining topics we will do in the next lecture. Thank you students, we conclude here.